Hello, you're listening to Inside iOS Dev, a show about real-world iOS development, here with your host, Andrew Rohn.
And Alex Bush.
And today we're going to talk about the Null Object Design Pattern and the law of Demeter. And Alex, I think, will be driving this mostly. Alex, what do you want to start off with?
I recently got an email from a listener sort of asking about that and about optionals in Swift, how to deal with them. It's a lot of if-elsing. Can we do better? And that's essentially what we're going to talk about today. Is what I explained. You know, the solutions that you could be applying and to help with that. First of all, I guess let's define the problem and what's the issue. Swift has Objective-C doesn't have optionals, and it just works directly with Neil, and you can send messages to Neil and nothing's gonna happen.
Right.
But Swift takes another approach, and they have optionals for that. And optional is an optional value, essentially.
It's a data type, isn't it?
I believe so, yeah. It's a type.
Yeah.
You can have
Like an int is different than an optional int. They're separate data types.
Yes.
Yeah.
And you can have a value. Effectively, what it means, you can have a value in this variable, or you might not. And
Right.
it's a nil.
Mm-hmm.
And one way you go about checking if you do is you if-else, you quote-unquote unwrap, maybe not quote-unquote, but unwrap the optional value, and you do this if lat equals, if lat value name equals your optional, and the first clause of if is going to be the case for presence of value, and you can work with it, and another one is going to be for absence of it.
So the if let, you do that on an optional, and you basically, on the first clause of the if let, that is, you have a value in there in that optional. If you go in the second clause, that means that optional did not have a value at within it, essentially, that
Right.
it's wrapping around.
Right.
Okay.
Yeah, and it's nil, effectively.
Right.
There is another way to work with it with guard. I keep confusing it. I think it's other way around. With guard, it's the first one when you don't
Right.
have it, and then second clause where you do. Something like that.
Right, and that's to prevent the nested if statements, right? You could just guard at the beginning of a method and then kind of exit gracefully and return early. And then the rest of your method, you can operate under the assumption that you pass these guard statements and that valid, useful data is there.
Right.
Right.
And so essentially, yeah, that's how you sort of work with it, right? And as you mentioned, the issue quite often that creeps in is the nested if-elsing. Very nested, very nasty if-elsing on those optionals. But another thing that people can do, which sort of mimics, I forgot to mention, which sort of mimics the Objective-C nil behavior, where you send messages to it, and if it's not there, nothing happens, is so-called optional binding, where you basically take your variable that you want to send message to, and if it's an option, you just put a question mark and say dot message, and if it's there, it's going to execute that method on that object, or if it's not going to do anything.
It just kind of hums along, keeps going, and ignoring that line.
Pretty much. And in a lot of cases, what I've seen people do, they would have an so-called optional chain. Basically, you can do the same thing with multiple objects. Let's say you have object A and it has a property object B, and you want to call a message on object B, but your object A is optional, right? So you would do A question mark dot B question mark dot method, right? And if any one of them is optional, it's just going to silently not do anything.
That's why it's called optional chaining. There's these chain of optionals.
Right.
Okay.
So that is what you could do with it. The problem, though, so we already kind of talked about a little. First problem with optionals is nested if-elsing and just or lots of if else's everywhere, checking on unwrapping and checking on the value, right? And you might not want to gracefully, silently, quote unquote, fail and not do anything, right? You might actually have to have the value and have different behavior if you don't. But again, a lot of if-elsing everywhere, a lot of optionals breed if-elses across the code base, and it's never pretty. It's difficult to work with. It's a cognitive overhead. It's just not scalable. And another, but again, the optional chaining helps with it a little, but the problem with optional chaining is that it breaks law of Demeter. And law of Demeter is the principle of least knowledge. Effectively, what it states that your object needs to talk to only its immediate objects that it knows about or creates, and it should not reach into other objects' properties, let's say, and ask those properties and objects to do something, because that's not least knowledge, that's too much knowledge about internal implementation of other things.
So just to make it clear really quick, so let's say we're in self, right? We're in a class and we're referencing a property A on self. What level can I reach into object A before I'm breaking the law of Demeter? So clearly me self reaching into my property that I have on self, that clearly wouldn't break the law of Demeter, because we couldn't have properties essentially if we couldn't do that. So like at what level does it break? When does it break down?
Anything beyond that A. So if let's say that object A has B, C, and D, asking for B, C, and D, and then working with them would break the law of Demeter. So
let's say I have a string actually on self, and I do self.mystring.count. Is that breaking the law of Demeter?
That is not breaking it, because you're asking you. So that's the other part of the law of Demeter. Ask, don't tell, right? You're asking for your string for the count. You're not asking it for the list of characters so that you can count yourself. And that's essentially the whole idea. You ask, don't tell. You don't tell your objects what to do with their inner objects. You just ask them to do something, which is sending a message to them. And then inside of that method, they will figure out what to do.
Okay.
Yeah. But again, right, that is sort of, again, the optional binding is what encourages you to break it, if you will, right? Because you sort of have it, and, who cares if one of those things is nil.
It's easy to just string them together and have this super long chain.
It's like enabling, basically. But there is a better way to go about it, and there are design patterns that can help with that. And one of them is Null Object Design Pattern.
Okay.
So essentially, the idea is that rather, if you think about it, nil, quite often, nil represents the absence of value, right? It's not just like a void, right? The emptiness. It's still a value. It just means that there is an implicit meaning that there is no value for that type, if you will, for that thing. And as an example could be current user object, right, or user object. That is, in many apps, you either have it if the user is logged in. So you have a user object, and that represents the current user and has username and full name and so on, right?
Right.
But it could be nil, which most of the time, naturally, we would assume it implies that the user is not logged in, right? But it's implicit meaning. What is, I guess, the better way to go about it is to actually explicitly represent that as another type. And if you think about it, that nil, that not logged in state, it's still a user. You still have a user, but it's a guest. And the null design object pattern kind of dictates you and it tells you that you need to have a common type for both, for the value case for your thing, in this case user, and the absence of value case, which is guest. So you either have a protocol that they share, let's say user protocol, and then you have two types, logged in user, current user, and guest.
Okay.
And they both adopt user protocol.
Okay.
Or you have an user commonly shared user
Superclass.
type, superclass, and those two inherit.
Okay.
But in both cases, you get the desired goal with the design pattern, which is a commonly shared type. And then the rest of your application, rather than relying on a specific concrete guest type or current user or logged in user type, they rely on user type.
Okay.
And now you eliminate, and the null case type provides default values. Let's say, if you're a logged in user, you have a full name, and it will, if some view controller asking that user object for full name, it will return the full name. But if it asks a guest user for full name, it's just gonna return some default value.
Maybe an empty string or something.
Maybe even an empty string.
Right.
Yeah.
So I have a question. So the null object in this case is the guest.
Yes.
Okay. So it's conceptually a null object. It's not actually a null object, right?
Exactly. Yeah.
Okay. And you just kind of formalize it. And then I think the other important piece you said here, they share a common interface, so you can safely send messages to either the null object or an actual object, and you don't really concern yourself with if-elsing, because the object will just respond to a message based on however you implemented it to. In this case, the null object, let's say, returned an empty string for the username.
Precisely. Yeah.
Okay.
And that is how you help with all of those if-elsing across the code base, right? You just sort of illuminate them pretty much everywhere where you were working with user that might have been absent.
Okay.
And in a nutshell, that is the null object design pattern. You can apply it to many other scenarios. I guess even what comes to mind, like parsing JSON, right? In some cases you have those properties, in some cases you don't. So you may have a default value instead, right? Or something like that.
Okay.
Yeah, it's applicable across the board.
In Objective-C, I know you have NS null. And then you can insert those. You can insert them into NS arrays, and that's a safe way of having an object type that you can insert into NS arrays that represent objects, right? Because NS arrays can only take objects. Does Swift have that same thing? Actually, I'm curious.
So Swift has generics, so you need to have a common type. Let's say a protocol, and in that case, again, back to the example of users and guests, you might have an array of users, and if guests and current user both conform to that protocol, then they both can live in that array. But yeah, I mean, Objective-C is more dynamic and allowing for that. I
guess my question is, how is this, the NS null, how is that related to the null object pattern? Is that an implementation of the null object pattern, or is that something else?
Not really. It's just something for Objective-C runtime.
I feel like that's kind of a quirk of the Objective-C language, right?
Yeah.
We're like a way of representing null
in
an array.
Yeah.
Thank you, Alex. I guess that's it for today.
Yep.
Find us on Twitter at InsideIOSDev. Check out Alex's book. What is it?
iOS Interview Guide.
Okay, and where can we find it?
It's there. iOSinterviewguide.com.
Nice. You've been doing, a lot of people have been getting that, huh?
Yeah, a lot of people.
You get a lot of emails from people, you tell me.
People not only getting it, people also getting jobs.
Yeah, which is, I guess, the more important part. Great, man. Thanks for this. Y'all have a good day.
Yeah, bye.
Bye.